In this video, we will be working with rational exponents, which are actually what radicals are. They are fraction exponents. So if you have a to the 1 over n, that's the same as the nth root of a. Or a to the m over n, the denominator of that fraction exponent is the type of radical, and the numerator is a regular exponent. So let's look at some examples. X to the 1/2 is the square root of x. So the denominator tells us the type of radical that we're dealing with, or the index of the radical. In the next example, the 1/3 exponent is a cube root. So this is the cube root of 2y. X to the 4/3, the numerator of the fraction is the type of radical or the index of the radical, so it's going to be a cube root of x to the 4th. And we could also write that as the cube root of x raised to the 4th power. That exponent could be inside the radical or out. We could also simplify that, since x to the 4th is 4 x's multiplied together. That would be the same as x cube root of x. And if we have a negative exponent, if you remember your properties of exponents, that's the same as 1 over t to the positive 2/7. You can move it down to the denominator and rewrite it with a positive exponent. And then I'm going to rewrite that with radical form, which will be 1 over the 7th root of t squared. Now we're going to go from radical form to exponential form. So in this first example, since we have a square root, we're going to have a 2 in the denominator of the fraction, and then the numerator is going to be a 3. So it's x to the 3/2. This next one is going to be, this time we have a cube root, so a 3 in the denominator and the 2 in the numerator. This next example, why don't you think for a minute, what do you think it will be? Did you get x to the 4/7? And in part D, since we have 2y squared with a cube root around the whole thing, I'm going to write that with parentheses to the 1/3 power. And that 1/3 power can be applied to each thing inside. So I could also write this as 2 to the 1/3 y to the 2/3. And in part E, this would be 5ab. Since the whole thing is inside those parentheses, I can write that to the 3/4 power. I could also write this as 5 to the 3/4, a to the 3/4, b to the 3/4. Now, recall all the properties of exponents. They are going to apply with rational exponents. So if we multiply exponential expressions with the same base, we add the exponents. When we raise a power to a power, we multiply the exponents. Negative exponents work the same way. If we have a to the negative m, we could rewrite that as 1 over a to the m. And if we divide exponential expressions with the same base, we subtract the exponents. In 7a, we are just going to be simplifying by changing this to a cube root of 125. And we know that 5 to the 3rd is 125, so the cube root of 125 is 5. 64 to the 1/2 power is the square root of 64, which is 8. And in part C, this would be the 5th root of 32. Since 2 to the 5th is 32, the 5th root of 32 is 2. Now we're going to apply some properties of exponents in part D. we're multiplying exponential expressions with the same base. So we want to add the exponents, just like in this property up at the top. So this is going to be 7 to the 1/2 plus 1/2 power. And 1/2 plus 1/2 is 1 whole. So we get 7 to the first, which is just 7. You could also think of this as the square root of 7 times the square root of 7, which is 7. Now in part E, same idea. We have -5, the same base, to the 1/3 plus 1/3 plus 1/3. And that makes 3/3. So we get -5 to the 3/3, which is 1 whole. -5 to the first power is -5. In part F, I'm going to apply this property right here. I don't have the same bases, but since I do have the same exponent, I could think of this as 3 times 75, both to the 1/2 power, which is the same as the square root of 3 times 75, which is the square root of 225. And if I recognize my perfect squares, I know that that is 15. Here's an example of a problem in context that involves rational exponents. The rate of inflation, I, that raises the cost of an item from the present value P to the future value F over T years is found using the formula below. Round your answers to the nearest tenth of a percent. What is the rate of inflation for which a television set costing $1,000 today will become one costing $1,500 in 3 years? Well, the $1,000 is going to be the present value, P. The future value, F, is going to be 1,500, and 3 is T. And what we're finding, the rate of inflation, is I. So I'm going to use this formula and just plug in the things I know. For F, I'm putting 1,500. For P, I'm putting 1,000. To the 1 over 3 minus 1, we can reduce the inside of the parentheses. That's 3 over 2 to the 1/3 minus 1. You could plug it in your calculator like that, or if you are using a TI-84 and you press Math and find the cube root, you could also plug in the cube root of 3/2 minus 1. Make sure the minus 1 is not under the cube root, and you should get 0.145. And if we move the decimal 2 places, that's the same as 14.5%, because the rate of inflation should be 8%. Part B, what is the rate of inflation that will result in the price P doubling? That is F equals 2P in 10 years. Well, T is 10, F is 2P, and we're just going to use P for the present value. So let's plug those in. We get, for future value, we put 2P. For present value, we just put P. And to the 1/10th power this time, minus 1, those P's cancel, and we get 2 to the 1/10th minus 1. And you can plug it in like that, or again, you could do a 10th root if you press Math and choose the radical where you get to pick what the index of the radical is, and you should get about 0.072 or 7.2%. Here are some last few examples. I recommend you try these on your own and see if you can figure them out. Pause the video, see how it goes, do them on your own paper, and then check your answers with my solutions when you're done. Okay, for this first one, 9a, If I apply the property of exponents where you raise a power to another power, you multiply your exponents. This is 81 to the 1/4 times 4, and 1/4 times 4 is 1. So this is just 81 to the first power, which is 81. In part B, anything to the 0 power is 1, always. In part C, we have negative 27. That's going to be a cube root, and then it's going to be squared. I could put that exponent inside or outside, but I'm putting it outside, so I do my cube root first. The cube root of negative 27 is negative 3. Negative 3 squared is 9. In part D, I'm going to multiply the 3 times the 4, and I get 12. And when I multiply x to the 1/2 times x to the 2/3, I'm going to add my exponents. Now to add 1/2 plus 2/3, I need common denominators. So I'm going to multiply 1/2 by 3 over 3 and 2/3 by 2 over 2, which gives me 3 over 6 plus 4 over 6, which is 7 over 6. So we get 12x to the 7 over 6. We could also write that as 12 sixth root of x to the 7th, which we could even simplify to be 12x sixth root of x. All of those would be equivalent. In part E, I'm going to apply that 2/3 power to both the 27 and the 8. It's going to be the cube root of 27 over 8 squared. The cube root of 27 is 3. The cube root of 8 is 2. And then I'm going to square both of those, and I get 9 over 4. And in part F, I have some negative exponents. First, I'm going to multiply my exponents because I'm raising powers to another power. So 2/3 times negative 6 over 1 gives me negative 12 over 3, or negative 4. So I get a to the negative 4. Negative 1/2 times negative 6 over 1 is positive 6 over 2, which is 3. So we get b to the 3rd power. And now I'm going to take my part with the negative exponent and move it to the bottom of the fraction, and we get b to the 3rd over a to the 4th.